All right, my name is Rob Marshall, and today we're going to talk about data management, table partitioning, and multi-tenancy. So we're going to talk about what this session is supposed to cover, and then we're going to talk about what is table partitioning, and then specifically what is multi-tenant. This session is about table partitioning and multi-tenants are two methods of securely dividing an OpenEdge database. One increases performance and scale, especially for business analytics needs, while the other can drive down costs, increase margins in cloud environments. So you're going to learn how to apply these technologies for a competitive advantage in this session. So what is table partitioning? Table partitioning, by proper name, is horizontal table partitioning. We're just going to call it table partitioning. That's what it's referred to everywhere. We have table instances stored in separate self-contained locations. As you see in the graphic, we have order dates, like in partition 1 and in partition 2. What's the difference? It's based on their date. One is 2012, one is 2013. Table partitioning is typically used in transactional deployments, OLTP. It's typically based on user-specified column values. Okay? So we're going to say in this case, it's based on order date, for the example in this one, less than December 31st of which year. So it's partitioning based on year datas. So that is different than based on a user identity. So Rob has access to this. This is based on myself as a user has access, and data is sliced based on the different groupings. A row does not span partitions. So if I have a data record and its order date is within one of those groupings, it's only in that grouping. It's not duplicated anywhere. It doesn't include, multiple people can't access different versions of that same record. So why partition? So why would we want to? The three main reasons: being able to maintain our system better, make it higher in the use of availability, increase those, nines of availability, and get some performance. So from a maintenance point, right, everybody does data archive, or most people do data archives based on a period in time. Depending on your industry, that could take a long time. You're scanning your entire application. You've got this big bucket of data that you now have to go through every single record and say, can I purge this? Can I move it to something else, a historical database, whatever? Within a partition, in the case of the previous example where it was based on years, say I only have to keep the last 7 years worth of data. Well, anything year 8 and older is a lot faster to find and get rid of. If I have to repair data from the availability point, or I need access to historical data, it's in its own silo. It makes life a lot easier to get to. From the performance point, how often do I look at 3-year-old data, 5-year-old data, versus the last 3 months? I can tune a little bit more of my database to give me better performance for the data that I reference more often. So what is it good for? Where can we use table partitioning? So its main advantages are for performance. Right? When we get data, we have to look at data within certain ranges. So that's where it really comes into play. It can add a lot of value for concurrency of those searches within that area. Higher availability of our application. Because now that we have data sliced into different partitions, if I have to do maintenance on those, it's a little bit easier. Where I can purge or archive data. Well, what happens to data that's over 5 years old, over 7 years old? Right now, if I purge, right, we could be going through the entire table and getting rid of everything. But if I'm purging and it's in its own partition, I'm only hitting that one partition. That process hits that partition and that's it. It can get rid of things. If I have to do some repairs or rebuilds, right? If I want to do some what we call pruning, where I can get rid of an entire partition. So anything older than 8 years old, so I don't need anything past that. I can take that partition and I can prune it, which basically is a drop of that partition. So my archive becomes a lot faster. There's less impact to things like the before image file, the after image file, any of the database things that could cause impact to my user base. So there's a little bit of disadvantages, of course, as well, because it's not perfect for everything. There are some different things, right? Our alignments and lookups. Whenever it has to do that, it has to say, what partition does this belong into? There's overhead. How much overhead? Well, I have to give you the standard answer of your mileage may vary. Depends on how complex your table partitions are. You know, that's one of the things you have to go through and you have to test. Another advantage, or disadvantage I should say, is where the DBA comes involved, right? They're human. Do they know a lot about the partitioning? Do they know the application? How is the application going to use all this stuff? A developer may say, yeah, I want to slice this based on, you know, the order date. But what if there's something else that has to be involved? Well, that may not be the best way of doing it. It may take some investigation and further analysis across all that. So what happens if they don't get it right? Well, we have to repartition that. And that takes, and in essence, costs. It's time and effort. And it is definitely a more complex deployment to get this to work. Right? It's not just taking your standard database, dropping it out there, having type 2 storage, and done. We now have to think about how everything is slicing and dicing. So once you do that, you have a little bit more complexity in your deployment. Some of the features of horizontal table partitioning, or table partitioning, is we can create named storage areas based on a column value. So you can call one, you know, 2017, 2016, whatever. Now, if we have a partition based on a single value, order date, or sales rep, for example, that is a list partition. If we base it on a value, so the example of that one would have been order date, that's a range, right? Standard lists, standard ranges. And then we can do combinations of those, which they call sub-partitioning. And then we also can go multiple values in a single column. If it belongs to Ohio and Oregon or Massachusetts, for example, right? I have multiple values within the same column of the state field. That's a composite partition. Now, typically a composite partition is primarily supported for a migration. I'm not sure which ones these are going to. I need to do some staging. The other two features that we have within this that are really nice is the partition level pruning, where I was talking previously about if I only have to keep 7 years worth of data, anything that's in the older partition, which is 8 years and older, I can eliminate it. The ever famous, you know, in essence of a drop of that area. And I can lock based on partitioning when I'm doing functions, such as online index rebuild, index activates, whatever. It's partition by partition, so it's less impact to the system. So in summary, our main benefits is we have a more focused maintenance process. We have more flexibility in how our data is partitioned within the application. So if somebody does a query and they're using one of those, for example, order date ranges, it's only going to be within one or more partitions based on that qualifier rather than the entire table, which it is today. And the best part of this is it's transparent to the application. The application does not need to change. It's all behind the scenes. It's database level. So some types of partitions. We have a list partition. The example that's in this one shows different regions. So I have a western region, I have a northern region, I have a southern region. If you want to think of it, lines of business, retail, wholesale. I have ranges. Of course, you see the examples in here is based on order date. So is it in the 2011 grouping, 2013 grouping, 2015 grouping, And then we can go into subpartitions. Now, subpartitions, we support up to 15 levels. I do not recommend going 15 levels deep in your partitions because that is an administrative nightmare. However, if I take a combination of that list and range, I have my western region, and then by each of those ranges. I have my northern region by each of those ranges. So I can subdivide down. Now you see the level of complexity went within this from having 3 lists and 3 ranges to when I combined those, now went to 9 partitions. So you can see where your maintenance, your setup, and everything else time comes into play. So let's talk about list partitioning. So we look for a static data value or something that changes very infrequently. You don't want your data bouncing between partitions because that's overhead. It's got to remove it from one, so you've got BI, AI activity, it's got to put it in the other. Right? You've got all your standard stuff with this. In this case, we have data organized geographically. Right? We can group it by specific entities. Give me a sales rep. By sales rep, SSS or whatever. We want to have exact matches when we use a list partition. Now, the other point in here is why or why not use sales rep? Well, accounts change reps. Reps leave. Accounts typically don't change what state they're based in. So consider the amount of data values. So on a table, the theoretical maximum is 32K, less a few. So 32,765-ish. Think of having to maintain and manage that many number of partitions for each table. It would become an administrative nightmare. So only use the number of partitions you need in order to make your application better. If you find that you're doing more queries within specific areas and you need to add another key, then think about it. Try it. Test it out in a development system. And wherever possible, we try to spread the data out. If it stays in one bucket, we have an issue. If we can spread it out, make it thinner, our queries run faster. They have less potential of a massive amount of records to go through. Range partitioning is similar. For performance, again, we want to spread the data out. You don't want to keep it in one large cluster. But the data is organized by a range of values rather than a single unique hit. Typically, year is the most common that we find. So that could be calendar year, fiscal year, order date, ship date, billing dates. Okay, take a look at all of that. Alphabetic or numeric ranges. Do I have something like a SKU? Do I have something like a customer number? Things that don't change a lot in that case, we'll see how it fits. But group your related items. Try to do a balanced spread if doing alphanumeric. We all know that if you start looking at names, when you look at things like A through P, if you took that as one grouping, it's going to be skewed compared to the rest of the alphabet because letters M, N, and O are usually very common. Subpartitioning. Do we add another column? Does it make more sense? Here's our trade-off. Do we want to have more partitions that are smaller for performance versus the overhead and maintenance time to make this happen? So in the case of our sample that we have, it's by region, by order date. So we went from 3 regions, 3 order date ranges, to 9 partitions. Indexing. There is a difference on indexing when we use horizontal table partitioning. So we have 1 B-tree index per partition. So where we're used to 1 index per table, I now have not just the 1 per table, but per partition of that table. So think about that when you're doing application changes. If I change a component of an index, it affects all those indexes that have that field as part of it. So I have local indexes, I have global indexes. A global index can go across partitions. So if I have a global index on order date, it goes across all the partitions of the years of order date. I can have composite indexes. So all of these come into play when you start thinking performance. So if I go to that 32,765 partitions that have, say, 8 or 9 components to it, what happens if I change one of those components? Every single index that has that as a section of that index component gets updated. So the amount of database activity can go up. So if you go too granular, you can actually cause performance impact. The restrictions. Anything with table partitioning has to be a type 2 storage area. Horizontal table partitioning cannot span multiple storage areas. That's not multiple extents of a storage area. That's multiple storage areas. Now, the only time we can repartition is by dump and load. So there is downtime, or there is an impact to your system. You can't have overlapping range values or gaps in your range partitions. Because if you've missed something, what happens if that data now goes in there? It's going to cause errors. You're only allowed one range component per table that's partitioned, and it has to be the last component, right? We want equality matches as much as possible up first, and then a range last. If you have multi-tenancy on a table, you can't table partition it. It's one or the other, not both. So we have some restrictions on our indexes. For local indexes, they always have to follow the partition definition. Word indexes, right? They are global indexes. They are not partition. So what is multi-tenant? So the big selling point of multi-tenancy is it provides data support to a number of separate and distinct groups of users for effective deployment and management of cloud applications. So again, think of lines of business within your application. I have retail, I have wholesale. Those could be separate tenants if your user base only works in one of those sections. So if I have call center folks that only deal with the retail side, it's a possibility. But if they deal with both, does it make sense? So in essence, it is a partitioning based on a user identity, a user at a domain. I am Rob at Progress. So some terminology that we have to get into within multi-tenancy. A tenant is a named group of users. So a certain population, if you will. They share the same application and the same data. So if you think of branches in a bank, one branch may or may not have access to the data in another branch. You've seen this in some retail organizations where you've gone into and they ask you for your phone number because you might be a frequent customer. Well, you might be registered in this state, but not this state because they're separate. So a multi-tenancy system is a deployment that supports multiple tenants, so multiple named groups of users. A default tenant is for users who do not assert an identity. So those that can access common information. For example, would be state data. Something that's common to everybody, but I don't need 50 copies of it in my database. We have a super tenant, which is basically an overreaching overall. So they can touch data in any tenant, so roll up data. And then the last thing we have is a multi-tenant group. I could belong to the group that is in Massachusetts. I could belong to the group that's in Hawaii. At that point, I'm part of 2 different tenants. I can see 2 different pieces of data. The next thing we're going to talk about is tenant types. So a tenant is a separate organizational entity. Notice how they've used the business words in there of organizational entity. It's not a section of data. It's usually a business split, or the reason for that is business related. Within a multi-tenant database with its own private data for each table. So I have the customer table defined once, but any tenant has its own slice of the data within that. If I don't belong to that tenant, I can't see that customer. So if I have a customer in Michigan that's, XYZ Sports, but I don't belong to that tenant, I can't see him. I can't interact with them, I can't do orders, I can't do anything else. I may have another customer called XYZ in Massachusetts that's a total different side of business. The only person then who could see that is somebody who either has access to both of those tenants or the supertenant. Now, tenants are used within ABL security domains. So we have to define those domains within the ABL, within the database, and they have their own users. So every multi-tenant database belongs to a domain or a default based off of that. So they either belong to the default or common tenant. They belong to what we call a regular tenant, which is somebody who has a slice of the data, either one or more tenants that they belong to, or they belong to the supertenant. They can do roll-up data. They can look at any single tenant they want to within that database. Usually the number of supertenant users is quite small. Now we get into a few definitions in this one. We have a table instance, which is a single table. Right? It has its own data. So where I was giving the example before of a customer, I have a customer. The customer is defined in one data definition file, but each tenant has its own amount of data within that table. So they have their own instance of that table. Now, in a multi-tenant database, we don't have to have every table as multi-tenant, because remember, we can split between table partitioning. We can have stuff that's multi-tenant, or we can have stuff that's part of the default tenant or common. So we can have a slice and dice in all of this type of stuff. And if we don't use a table, we don't necessarily have to have it defined. If a table is, for example, customer, and I don't reference customer data at all, I don't even have to assign that tenant to my domain. I just never see it. I can see its definitions, but I have no access to data. In the SQL version, it's like looking at a SQL catalog, but without being able to select anything within those rows. Now we have data segments. That's a tenant or group that has a specific chain of data for each table, index, or large object, whether it's a blob or clob. They're stored in their own physical data partition. Again, here's where the DBA starts to hate you, because they have to go out, they have to define everything. Now we have physical data partitions, which are managed storage for each object of the multi-tenant table. And they do not span a storage area, because in type 2, a table is in one storage area. Well, I'm now going to have multiple areas within that to make it work. It's like the horizontal table partitioning. We go through and do a lot of things that way. So what happens? We have a user who can log in a number of different ways. They just log in without a domain. So what do they have? They're part of a blank domain, and they only normally have access to what's called the default or common tenant. So they can look at the, for example, state tables. They can't look at the specific data within any one tenant for a customer. So if the user logs in as a member of a domain, say Michigan or Massachusetts, that's not blank and it's not a supertenant, they have access to just their data that they have rights to see and anything that's in the default. But if a user logs in as a supertenant, they really don't have a tenant of their own, but they have overriding access, so they can get temporary access to any regular tenant's data. This would be roll-up information typically, business intelligence at a corporate level, those type of areas. So for table types, we have non-multi-tenant tables, which are shared. Okay? If you take a look in the sports database, you may want to use things like the state table. It doesn't make sense for every tenant to have their own copy of a state table. Right? You'd go through and everybody references the same thing. If you change it one place, you change it everywhere. In some applications, it might be, your control tables, your reference tables that don't change. Price books that are at a corporate level. Things like that. Any temporary tables, any schema tables, those are shared. They can be accessed by users of any tenant that has access rights or normal access to those tables. So if you have database level security that says can read, can write, can update, can delete, that still comes into play. For multi-tenant tables, those are tables that have been made into multi-tenant in a multi-tenant database. Because when you turn on multi-tenancy, you have to turn it on at the database level. And then once you've done that, you can start moving tables into a multi-tenant structure. So they have a number of different things. They have private data segments, and they have default data. So user access to tenants. A default tenant user cannot access other people's information. So if you're part of the common area and you haven't logged in with a tenant that has access to, say, customer data, you can't see it. The database won't let you. If you're a regular user that's logged in, say in the state of Massachusetts, you can see any data that's for Massachusetts and stuff that's part of the default tenant or common. That's all you can see. You can't see anything else. For super tenant, well, you have to go through and use a few language constructs to see the different tenants. By rights, you have access to those tenants, but there's a couple of ABL command language constructs that you can use. Set effective tenant and tenant where is where you can set, I want to see the data in specifically Massachusetts or Michigan or Hawaii. Access within that is still subjective to if you have access rights within the database or potentially the application. As with horizontal table partitioning, this has to be a type 2 storage area database. You can't use table partitioning on a multi-tenant table. They have to be one or the other. They can't be both. And the domain needed for tenants has to be set with the client principal object. And we've been supporting both of these since version 10. So I'd like to thank everyone for being here. And if you have questions, my email is in the bottom side of this. Feel free to reach out. I will respond as soon as I can. Thank you.